Good morning, everybody. I'm happy to welcome you to our latest Bathy database webinar titled the CARIS Bathymetric Data Management Solution. Just to run you through the schedule for today's presentation, I'll proceed with a slideshow interspersed with some live demonstration. This all will take about 30 minutes. Presenting today is Karen Cove, that's me. I'm the product manager for Bathy database, and I have with me Mike Van Duzy, who is our lead developer for Bathy. What we're here to talk about today is Bathy database. It's a comprehensive bathymetric data management solution. Along with database storage for your bathymetry data holdings, we also provide a great number of analysis and compilation tools in the client environment that connect to the database. The system provides flexible support for many data sources and formats, and by that I mean traditional GIS formats like vector formats, raster imagery, surfaces, point clouds, etc. It's key to point out that Bathy database is a product that's been on the market for 7 years now, and it's used in full production in many large charting organizations. It's an integral part of CARIS's ping to chart solution, and if you're wondering what that is, ping to chart means that you can use CARIS tools right from data processing to chart production and the subsequent distribution of marine information and chart products. The solution offers seamless data transfer and interoperability without having to switch between different software systems. And CARIS is the only organization with that type of solution on the market. Now, for those of you who aren't existing clients, a little bit about CARIS. We provide GIS software primarily for the hydrographic and marine community. We've been in business for about 30 years, and our software products are in production all over the world. We're a group of about 170 people in 4 offices. We're not a huge company. We think that's a good thing, though, and we very much focus on the marine GIS domain, and I'm happy to say that we're very good at what we do. Our technical support and development staff, in particular, are quite involved in the use and development of various standards. This is something we're very proud of, and our own Mike Van Duzy, who's with us here today, contributes to the Open Navigation Surface Working Group that maintains the bag format. That was a little bit about CARIS. Now a little bit about who's using Bathy database. As you can see, Bathy database users vary from hydrographic organizations to port authorities to scientific organizations and even private survey companies. Those listed on the slide are just some of our users, just so you can get an idea of who's in that user community. When we started out with Bathy database back in 2005, the main focus was very much on the preparation of bathymetric features from base surfaces for your traditional electronic and paper chart production. But in the last few years, the scope of the workflows and products coming out of Bathy has grown far beyond the original intention. People are using the tools to produce a number of informal or non-standard products like daily pilots updates. They're doing coastal zone maps and even updating charts with laser scan data now. So why are all these different organizations using Bathy database? And the reality is that whether you're a port authority or a national HO or an oil and gas company, you probably have a huge amount of data to manage, and you could be getting more value out of your data if it was well organized and easily accessible. Many people are looking to move beyond a file and folder and naming system to organize their data, particularly as the mandate to make data more accessible is becoming a more urgent need. Particularly in the EU, we have the Inspire directives, and other governments have similar mandates that they have to meet. And as well, the desire for very efficient workflows and quick turnaround time for products is becoming more critical for a lot of organizations. We're going to take a look at the basic structure of the collection of software we call Bathy database, or as we call it in the office, BDB. We like our acronyms here at CARIS. We have a desktop application called Base Editor, and this is where all the raster and vector data analysis tools live. Base Editor stands alone, so if you aren't looking for a full data management solution, but just need a flexible tool to bring together different sources of data, do some analysis and manipulation on rasters and point clouds, do things like make features like contours or other chart features, then Base Editor is the app for you. If you need to manage a port or waterway or some other infrastructure, then you would likely be interested in the engineering analysis module that can optionally sit on top of Base Editor. And if you are looking for that full data management solution, then you need the Base Manager module, which gives you all the tools to access the data stored by the BDB server.
And just note that all of these applications and modules are available in both 32-bit and 64-bit versions to help take advantage of your hardware setup. And for anyone not familiar with any of the CARIS applications, please feel free to download our free viewer. It's called CARIS Easy View. And it's essentially Base Editor without the licensed tools. And you can find that on the CARIS website.
All right, let's also have a really quick look at the server architecture here. We see the different clients that can exist for the server and that the BDB server uses an RDBMS or relational database backend. You have the choice of using Oracle, Spatial, or Postgres. Generally, large organizations have opted for the Oracle option just because they already have all the Oracle support systems and DBAs in place, while most of our smaller clients have tended to use the free Postgres SQL solution.
And even though Postgres is a free open source database, it's still very capable. In fact, it's a very, very powerful database.
I personally like working with Postgres because it's quite straightforward, and for us non-DBA types, it's easy to set up and maintain. Let's take a few more minutes and talk about some of the fundamentals about how we designed BDB Server. As I mentioned, it uses a RDBMS backend to manage both the bathymetry and the metadata. The primary object in the database model is a surface object. Each data set loaded into the database gets modeled as a surface object. You can optionally use something called a survey object to organize the surface objects into a group. And that's just meant as a way to separate project level metadata from the individual surfaces that make up the project. The surfaces are either stored in CSAR or Oracle native format, and both of these are very efficient ways to store data. Additional documents or supporting material can be added to surface objects as attachments, and this allows the system to truly work as a source data repository. Now, metadata is absolutely fundamental to the system, and we're going to talk about how it's handled in detail in a few minutes. But first, let's talk about why we use the RDBMS backend. We started out originally with a file and folder system 7 years ago, and as the system matured, we evolved the technology to use an RDBMS backend. What are the advantages of managing both the data and the metadata in the RDBMS?
Well, the RDBMS lets us keep data all in one spot instead of it being distributed among many computers. Now, that's not to say that you can't maintain data across, say, a cluster of servers, because you can, but you'd be doing this in a much more controlled environment. The data is not going to just be scattered among, say, random computers on your network, because as we know, some computers get turned off or maybe disconnected from the network. When the data resides in a relational database like, say, Oracle, it's always available, and you're going to have a DBA there to ensure that it is regularly backed up in case of any hardware failures. Now, another advantage is consistent data performance. When various file formats are used for data storage, the performance of the system will greatly depend on the efficiency of that format. So say formats such as ASCII or BAG will not perform as well as a CSAR or Oracle raster type. We still support many formats, but we'll convert these to the more efficient types upon load. And finally, The database backend provides far superior data security and configurability than what you can accomplish using a simple folder structure.
So it might sound like a great idea to have a database full of ASCII files or bags, but when we think that these are typically exchange formats and not necessarily the best storage formats, it may not work out all that well in practice. So we were just discussing the storage of data in our CARIS CSAR format. Mike, can you tell us a little bit about CSAR and what makes it so great?
Well, CSAR, or CARIS Spatial Archive, it's really made up of two pieces. The first is the file format, and the second is the framework that we use in our software. Both have been designed to be flexible enough to support multiple data types. We currently use it for gridded data, point data, and imagery. And in fact, our R&D team is currently working on adding variable resolution support for an upcoming release. It is also very efficient and scalable. So by utilizing an internal multi-resolution pyramid structure and data fragmentation, we can handle terabyte-sized data sets that will open and draw almost instantly. The CSAR framework also supports multi-threaded processing to help take advantage of the newer multi-core processors coming in computers. And something that we are very excited about is the soon-to-be released GDAL plugin for the CSAR raster format. GDAL, or Geospatial Data Abstraction Library, provides a single interface that allows reading and writing of about 130 different raster formats. It's open source, so anyone can contribute to it, which is one of the reasons why it continues to grow in popularity.
So Mike, what is the CSAR plugin going to let you do?
Well, the plugin will allow access to both the individual pixel values in the CSAR raster file and its ISO 19115 metadata. It'll also allow you to convert other, maybe not very efficient formats into the CSAR raster format.
Does that mean that other software vendors are going to be able to read and create CSAR rasters using the plugin?
Yes, it does.
Now, I believe that we are initially going to be posting that CSAR plugin on our online customer services site, but I don't yet have an exact date. Now, is it going to be licensed?
Well, yes and no. It will be unlicensed when reading or writing CSAR rasters that are stored on your local disk. A license will be required for reading datasets directly from the Bathy database server, though.
That all sounds good. On to a bit about the analysis and compilation tools that you're going to find in Bathy database. You can see we support opening many different formats, including our own CARIS formats, and lots of different third-party formats, either natively or through an import process. In the next big release, we'll be supporting even more formats. And do you want to tell us why that is, Mike?
Well, in our next release of Base Editor, which is version 4.1, we are going to be taking full advantage of the GDAL library to allow us to read many new raster formats. So the users are going to notice a lot of new formats in our file open dialog.
I heard that it's even going to include formats like GRIB, which I think is cool. And with the formats we are reading using GDAL, am I going to be able to do all the things like shifting and contouring and operations like that?
Yeah, once because of our CSAR framework, once a data set has been opened, either it's say a CSAR on local disk or a GRIB file opened through GDAL or even a CSAR that's been opened directly from the Bathy database server, you can run any of our processes on them.
And of course, besides raster, we can open all the usual vector formats like shape and DXF. And as you would expect, we can view that data in both 2D and 3D. And the 3D viewer lets you do things like draping, applying color maps, shading, and making movies. Lots of different analysis tools, differencing, shifting, combining. You can create new computed layers, do horizontal coordinate system shifts, or transformations. You can make and edit tins, lots of different things. particularly in the BDB 4.0 release that we put out late 2012, we added a new grouping mechanism. And speaking of that, I think we'll switch over and demo for a couple minutes here. I'm going to open up some bag files. When I first open them, you'll see that they're all separate files, and they're all being displayed using a color map applied to their individual data range. But if I want to work with these as a single entity and make it a lot easier for me to do analysis on this data or compare it to other things, I can do something called creating a new group. So I'm going to call this group bags. And I'm going to choose to group all the rasters that I have open into this new group. And now we see that we have this group that has the sources we added to it. And there's only a single elevation layer that we now can apply a different color map to. We could filter the display to only show us a certain depth range. We could choose to display this as digits or whatever. I can also go and, of course, look at this data set in our 3D viewer. So it just allows you to work with a large number of data sets very, very easily. I could make a movie here if I wanted to. And just to give you a little peek at the tools, most of which are here under this tools menu, you'll see all those things I mentioned, like tools to create and manipulate tins, our combine function, differencing, extracting, interpolating holes, generalizing the surface, shifting, many, many different things I can do to these data sets. So I'm just going to get out of 3D and we'll go back to our presentation and we'll do another demo in a couple moments. Back to this slide for a second. One workflow that a lot of people have been using Base Editor to achieve lately is bringing land and sea data together. We worked with a client several years ago to incorporate some new tools for facilitating the creation of integrated coastal products. And since then, a number of other groups have gone on to use Base Editor to do similar work. We'll be actually doing a workshop at Coast GIS this year in Victoria that focuses on this workflow, as there's some special challenges that come up when working with land and sea data. Similarly, we've been working with clients to incorporate the tools needed to do laser scan and LiDAR analysis together with multi-beam data. And there's similar types of challenges that come up in that type of workflow. For those in the business of maintaining a port or waterway or some other coastal infrastructure, we have this engineering analysis module that can sit on top of Base Editor. You can access all the tools that you saw in Base Editor, but you can also create theoretical models and bring in existing models in the land XML format. You can do analysis to compare the model to the measured seafloor and do things like dredge volume computations and analysis. You can also do shoal detection in waterways, and there's a nifty little report generating capability to easily get the information into the hands of those using the facility. Now we've looked at the Base Editor application and what we can do with it. Let's take a few minutes to talk about working with the database. So when you have the complete Bathy database client server set up, it gives you a single point of access for all the data. Remembering that you can store both grids and point clouds in the database, and it can be data from wherever. Remember that. It can be brand new high resolution multi-beam. It can be your historical lead line surveys. It can be laser scan data. It can be coastal LiDAR, really whatever. The use of the RDBMS backend gives you all the stability and security you need to feel confident that your data is being well looked after. And we mentioned a little bit earlier that metadata was fundamental to Bathy DataBASE. Mike, can you expand on how we handle metadata in the system?
Well, just like datasets come in many different formats, so does the metadata for those datasets. And how we handle metadata is really a fundamental part to Bathy DataBASE and also the entire CARIS ping to chart solution. Because both the incoming metadata and the metadata that's maintained by an organization will vary, we provide a number of different mechanisms like style sheets and plugins for creating, maintaining, and mapping that metadata. One of the end goals is for that metadata to come through into features that you create from the dataset stored in the database and through the discovery portal used to serve the content of the database up on the web. While we do work primarily with ISO 19115 metadata schema, we also offer users the ability to customize the attributes on the surface object in the database. So this gives the opportunity to add all of the non-standard metadata that may be important to a particular organization, like maybe a project identifier.
Now, Mike, on the last part of this slide, it says that we can do Python scripting. Can you explain that a little bit?
Well, we put Python bindings on most of the server operations, which means that you can script your own workflow now.
So could I script some procedure like making a spatial and attribute query, then updating some attribute value on the surface objects based on what the query returned to me?
Yeah, and what's really powerful is combining our Python scripting with our new GDAL plugin, because GDAL also has Python bindings. So what this would allow you to do is say, query some surfaces in the Bathy database, open datasets up, and maybe run some custom analysis tools on them. Now, along with the Python, we also provide command line data loader and plugin interface to populate the Bathy database.
Well, that sounds good, and I think this would be a good time for us to do a quick demo here, showing people what it looks like when we interact with the database. So what I'm doing here is I'm going to connect to this training database, and you'll see here there's this query layer, and it's called, the query that I have made is called all data sources. So that's basically going to show me everything in the database. So here we go. This is the Shallow Survey 2012 data from Wellington. And if I take a moment, I can do things like open a data set from the database. So that's some laser scan data. I can open some raster data as well. Maybe I didn't want to see the entire contents of my database though. So I can do things like make a different query on here. So I'll make a new query. And this time I just want to see LiDAR data in this particular area. So I'm going to use this pre-canned little LiDAR rule. It's where the technique of sounding is equal to LiDAR type. And click OK. And I had already called something that. So I'll just change the name of my filter there. And now I can see that the only data sets that I am shown now are these ones that meet my query. I'll turn that off and I'll go back to my original query. something I can do now that I have some data open from the database. And remember, this isn't on my local machine. I haven't exported these data sets. I'm just looking at them locally. I can go into the 3D view and I can look at this LiDAR data along with my multi-beam. Let's have a look at what that looks like. So we can see Wellington, and we can see the docks, and I'm a terrible navigator here, so bear with me. But we see from the LiDAR data the shape of the ships at the pier. So that gives you an idea of what you can do with the data that is directly drawing from the database. And remember, if we have something open from the database without even bringing it to our local machine, we can do all kinds of different things with it. We can combine various data sets into a single product surface. We can do contouring of our multi-beam data. All those types of things that you were able to do in Base Editor, we can do here as well. Another thing that people often want to do is actually exporting the rasters directly to the BAG format right from the database. So you don't even ever have to export it. You can just send it out to BAG and send that to a client. All right, on with the presentation slides here. I mentioned a minute ago that one of the things that we do a lot in Bathy Database is combine different data sets together. And that's something that has proved to be a very popular tool with our users. It's extremely flexible. Users can combine data sets with very simple rules or with very complex rules. You can define a whole hierarchy of rules using all the metadata available to you, from the dataset metadata right down to the values on individual pixels. And that makes it extremely flexible, and it really sets us apart from what some others are offering in terms of similar functionality. The sources that go into the combine can be local files or data sets in the database. They can be either grids or point clouds.
Now, in addition to this kind of combine where we write the results to a new file, we're also looking at incorporating other methods of modeling data, like generating on-the-fly mosaics.
That's great. And remember that Bathy Database isn't just about data management. A lot of people use Base Editor on its own for making products. And that can mean a raster product like generating BAG files, or the new S102 deliverable, which will include an improved carrier for the data like BAG or floating point geotiff, and the metadata that meets the S102 profile, or even just the metadata itself as an end product. And of course, lots of people use Base Editor in S57, AML, raster chart production. So contours, depth areas, soundings, and other chart features becomes the product as well. Another kind of vector product would be something like the Seabed survey data model, where we would export vectors to Seabed ML. And of course, even a document like a geospatial PDF is a product, or an image or movie made in the 3D view. On to how we handle data discovery and distribution in CARIS. Spatial Fusion is an OGC web server and viewer that connects directly to Bathy Database for discovery and distribution of marine spatial data on the web. It allows you to fuse high-resolution bathymetry and chart features together with third-party GIS data from database sources and file-based sources. It allows organizations to achieve data sharing mandates. As I mentioned, right now, there's that big push for government agencies to get their data online in the EU through the INSPIRE directives, as an example. One interesting project that I wanted to share with you all, here we have a user who wanted to integrate several layers of data into their decision support system, which is a web portal. The image that you're seeing on the screen shows bathymetry residing in the B2B server alongside vessel positions and vessel draft provided from the Exact Earth AIS web services. The bathymetry is actually being corrected to show real-time currently available depth, and the end user, the Port of Montreal, wants to use this data to monitor vessel traffic in the area and evaluate whether the vessels are operating within their guidelines. And we thought that was just a good example of a client serving their bathymetry data up on the web as a decision support system. Now, our focus for development in the coming year is very much focused on tighter integration with our chart production tools. We're looking at adding some geometry and topology validation tools in Base Editor and making the entire process around creating soundings and other features directly from gridded and point cloud data more flexible. A lot of people are using laser scan and different sources of data, so we're trying to make that entire workflow more flexible for people. We already mentioned the use of GDAL to open raster formats that we didn't previously support. And we already talked about the plan to expand on tools to combine or mosaic different data sets in the view and to file. And one thing that has become extremely important to CARIS over the last few years is to expand on all our activities that make the CSAR format and our tools more accessible to the user. And this means the automation of processes and the accessibility of the data itself. If you would like to get a hold of CARIS, it's very easy to do. You can come check us out on CARIS's YouTube channel. We're on Facebook, LinkedIn, and Twitter. We also, for our Bathy database users, host a user forum where we have technical discussions about the tools and topics relevant to the community. And as well, if you want to talk to somebody in person, we'll be at US Hydro in a week or so. We'll be at Ocean Business in the UK, and I'll be at Coast GIS in June. And we're also at FEME and a few other events coming up in 2013, and hope to see you there. Thank you very much.